What I wanted to say as we wound up wrapping up here is that we've really obviously only touched the surface, right? We saw a couple of examples of semi-real-world workflows, like in what you saw with Kyle and what I showed with LIGO IPython notebook last time. But there's a whole lot more to be done with the language. There's the language primitives themselves, like decorators and context managers and things that we just didn't have time to cover here. But I think you've now basically seen all of the basics. And so hopefully when you are presented with some Python code from somebody else, you'll understand what's going on. But there'll be some other pieces that may be still somewhat foreign to you. So rather than go through a whole bunch of different exercises, I thought I would just focus on one. This notebook is linked from the website, from the schedule page. Instead of going through decorators, and you can see that yourself, what I thought we might do is just show an interaction of us basically interacting with databases and then sending emails from Python. So this might be something that isn't potentially science itself or research itself, but it's a recognition, and you heard some of this in the panel discussion, that some of the other languages which might be really good at, say, doing statistics have a very hard time kind of interacting with the world. And that's one of, I think, the most beautiful things about Python is that there are so many different ways that you can interact with other code bases. So what we're going to do here is we're going to create a database. And there's lots of different types of databases out there. It's certainly beyond the scope of what we're going to do now to talk about all the different types. But there's one that actually is quite easy to interact with, and that's called SQLite. This is what's called an embedded database. So this doesn't have a server running like Postgres or MySQL, but is instead effectively a glorified binary file that lives on disk. And there's a very well-defined API for connecting to that file and interacting with the data in that file as if it was a database. We're also going to bring in some stuff from built-in support for email. And just because I'm going to wind up bringing in a file that has passwords in here, I'm not going to show you what that is, obviously, because that's my password. We're going to wind up importing that file, which is on my disk. And we're also going to do some logging information here. So I've created a couple of different functions here. One is going to create a table. This is a database table. And the way I do that is connect to a file name, which is going to wind up, we'll have a default file name associated with it. And then whenever you're dealing with a database, you often will wind up grabbing what's called a cursor. And then the cursor can do things to that database. So the first command we'll run is we're going to wind up creating a table, which we'll call tennis folk, which is going to have first names, last names, the email, and what kind of tennis player they are. And then we're going to insert some data into that table. So I'm going to input my name. I'm going to input Fernando's name. Sorry, we're going to kill all this. Actually, I'll go up into full screen mode. We'll input Stefan's name, my friend Wayne, who plays tennis, my friend Andre Agassi, and my friend Rafael Nadal. Is there anyone else, by the way, who's a tennis player here? Who's me? What's your name? Becky. What's your last name? How do you spell it? R-E-I-S-S. And are you committed or a casual player? You're committed. Great. We should talk later. All right, so we've got a bunch of people we're going to add into this database. And we're going to basically execute that when we run it. So we'll see what that does later on. I'll run those sequentially. Then we're going to actually have our ability to retrieve a random tennis player out of my database. So I'll connect back to the database. I'm going to use this random function that's part of the SQLite API. And I'm just going to grab one out. And I'm going to return back the results of that player. And I'm going to email tennis players as well. So if I have their first name, their email address, and their last name, I'll wind up automatically constructing an email address. And I'll ask them if they want to play tennis with me. And I'm going to connect to Google's SMTP server, which is the mail server. And we'll do that we'll do that securely using the password, and we'll wind up sending out the email. And then for me to actually just play tennis, I'm going to randomly grab somebody, and I'm going to wind up sending out an email to them saying, hey, you want to go play tennis with me? All right, so let's see where it is that we actually wind up setting that person's email address. So actually, Becky, what's your email address? At yahoo.com. Okay, thank you. Let me just run this file here. Okay, so I wrote that file. I'm going to run Appetite. Now let me create my friends table. There I inserted all these people into my SQLite table. I'm going to retrieve a random tennis player. There's Raphael with his email address. And there's you, just randomly showed up. And now I'm going to call the play tennis. So what is play tennis going to do? It's going to randomly pull somebody from my database and send them an email and say, hey, do you want to play email with me? Or you want to play email? You want to play tennis with me? Let's see if that works. Oh, I emailed Andre Agassi. Oh, I just emailed you. Can you check your email address and make sure that you actually got it? You have to say yes, by the way, even if you didn't get it. It may be in the spam folder. Anyway, so while Becky's pulling that up, I just wanted to show you in what is probably less than 100 lines, we're able to interact with the world, right? We interact with the database, add some data there, able to do emails. And obviously I didn't just bang this out and have no errors while I was banging this out and building out this notebook. I obviously was doing this somewhat interactively. But you can see hopefully just a little bit of what you might get with Python. And the nice thing, of course, is that if you are now not sending out random emails to people that you're randomly pulling from a database, but instead emailing like your lab manager or sending a text using, let's say, the Twilio API that you can get with Python and sending a text message to you when your lab's on fire, there could be potential use for a lot of things within Python. So there's a bunch of other things in here, like with web scraping. I'm not going to go into all those details just in the interest of time, but I just wanted you to see that using some basic built-in stuff with Python, we can get a lot of power out of that. How are we doing? Did you get an email from me? Not yet. Yay. And what does it say? Yay. All right, good. So it worked. Live demos are always extremely scary. but it worked out for us. All right, so let me just wrap up with a couple of thoughts here. What's next? Well, now you know how to do science with Python. So let's step through what science actually looks like. So in a very volatile piece of code, you need a try except statement. From my prior experience, you want to import insight and serendipity. You want to call out another function which generates new ideas, given some new technology. If you can't come up with anything unique, as many of you know in academia, you just copy somebody else's. Then, of course, you just need to get some funding. So if you want to start off, you're not funded, sorry. And while you're not funded, you got to keep writing proposals, and then you need to wait for about 6 months. If it was funded, then set the variable funded to true. And then that's great. You break out of your loop and you can do some work. So you can create a multi-processing tool, instantiate that pool of people with, let's say, 5 grad students and a couple of postdocs and a bunch of undergrads. And then you get a bunch of data, but you need to use some of your proposal cache. You're going to find a result. You're going to write a paper. You can submit that paper to Science, which gets accepted immediately, of course, without revision. And then you just add the results to your CV. You collect the prize. You're mostly just going to thank your grad students and not your postdocs, et cetera. Sorry, this is the cold world of science. No, obviously there's a lot more to do than just the single file here. So where do you go now, now that you're a graduate or almost graduate of this boot camp? Obviously, the web is your friend. There's great documentation on python.org. Thankfully, none of you mistakenly typed python.com, which is not safe for work. The PyPy, which is the place where pip goes when it tries to grab a package, is what's called the Python package index. This is a place where if a name for a project hasn't been grabbed, you can actually go and grab it. And then you basically can own that project and you can contribute to it and do whatever you want there. Some of the best packages exist there. This is not typically the place you would go to look for new packages. You would typically do that Google or Stack Overflow or somewhere else, but this is sort of one of the main repositories. So I guess R has its own sort of main repository where people will upload code. Stack Overflow, as I said, is a tremendously active place around Python. Lots and lots of questions being asked and answered there. And typically when you Google and you ask a question, the first thing that comes up is a question just like that was asked on Stack Overflow, and it will take you there. Reddit is actually a pretty good place to learn about new things that are happening in the Python community without having to sit on all the different mailing lists. The subreddit Python, I was super excited when a talk I gave a couple years ago was on the top of the Python subreddit. You're going to start instilling good practices of Python for all your children as you wind up having them. And IPython itself, which is slightly more active for now than the Jupyter subreddit, is also a great place to learn about the things that Fernando and his team are building and all the different things that are happening there. Quora is an interesting place to ask interesting questions. So one interesting question is, why did Quora decide to use Python? There's from one of the founders of Quora, there's a great answer to that. So that might be a fun place to look. Quora has what is probably one of the coolest web pages about Python, which is all the little tricks and all the cool little things that you can do in Python. So there's about 50 or 100 of these things by now. I encourage you, now that you understand the Python syntax, to go through and try some of those things out. What do you do locally? Well, many of you have heard us reference this, the Institute for Data Science here at Berkeley. This houses a number of people who are quite good at Python, and many of the core contributors to the various packages within Python are done by some of the people that are there. So BIDS actually is one of the homes of Jupyter and the Jupyter development. Stefan, for instance, is the creator and one of the core contributors to scikit-image, et cetera, et cetera. There's a number of people there that are doing domain science or methodological science, but also spending time on things like Python. So if you have questions, a good place to just show up is at BIDS, which is in Doe Library. So I encourage you to go there and interact with people. You can also do this with a very active community on the Berkeley campus. If you go to python.berkeley.edu/community, you'll see all the different things that are happening on the campus here, from the Hacker Within, which is a weekly meeting about scientific computing, to various different news groups like Pi for Science, et cetera. There's an active group at the D Lab who are also working on Python. So no real excuse for you not to have the resources that you need locally, both virtually and real, for you to be able to continue to grow with Python. I am now teaching a course which begins on Friday called Python Computing for Data Science, where we're going to go into essentially deeper notions of a lot of the topics that we touched on here. That's typically taken by upper division undergrads and first and second, third year PhD students. We've also had postdocs sit in on a couple of the different lectures. So you'll get a much more in-depth look at Python and the utility of Python for doing sort of real-world workflows. So definitely would be happy if any of you would like to join that. That's meets Fridays from 1 to 4, and it's a normal course. The course number is AY250, that you can look that up and join it by normal means. Just as an interesting side note, I used to call this class Python Computing for Physical Science. And the first time I taught the class, I had 4 people take it for credit. And then the next time I taught the class, I had 8 people take it for credit. And then I was like, I'm going to change the name. So I changed the name to Python Computing for Data Science. And then the next time I taught it, I had 55 people take it for credit. So names are actually very important. I didn't change the syllabus at all. This will be the first time, just so that many of you know, that we're going to do this in Python 3 and not in Python 2. So if you've forgotten, just to remind yourself about the Zen of Python, here's some candid pictures. I know none of you signed waivers to say this was OK, but I did it anyway, of just some pictures from the boot camp. This time, if you type import this on the command line, you'll get back the Zen of Python. And last, I'll just say thank you. This has been wonderful for me, teaching all of you a whole new crop of Pythonistas. It's been really wonderful to have the support of a number of the counselors here, so thank you as well. Please don't leave without giving us some feedback. And that's it. You can declare yourself knowledgeable about Python, and I hope you use it in the rest of your life. Thanks, everyone.